So for Peter and Christina, you both work on a catalyst. So how do your goals different with each other on hydrogen production and ammonium cracking?
Okay, the main problem regarding to the design of new catalyst lies in the endothermic nature of the reaction. That means that it requires a relatively high temperature that can limit the durability of the catalyst, but also can decrease the overall process efficiency. So our main objective is to develop a catalytic active phase that are active and stable at lower temperature by improving their physicochemical properties. I don't know, I'm thinking about basicity, acidity, but also we know that ammonia decomposition is a structure-sensitive reaction, so we need to increase the dispersion of the metal phase, also to increase the metal support interaction. Moreover, an important part of in which we are involved in the ANDREAH project is the use of POCs, so structured systems. I think they play a key role in the intensification of the process because they can improve the mass heading transfer, and also they can enable the development of compact reactors, and moreover, most important, they are compatible with membrane interaction. And finally, another critical challenge is the use to reduce the amount of critical raw materials according to European regulations. Indeed, in ANDREAH, the objective is to avoid the use of ruthenium, that we know is the most active phase for ammonia decomposition, or reduce the quantity at maximum 1%. Obviously with high activity at lower temperature that we are investigating.
I don't think that our goal is different. I think at the end we want to achieve the same thing, to make new catalysts that's quite robust and can actually be used to make ammonia at moderate temperature. But then the technology, the material itself, might be different. So we work on hydride based materials, and Christina explained, the thing is that we need to go to high temperature to do this reaction, and it's related to the fact that you need this high temperature to overcome the activation barrier to break the very strong bond of dinitrogen. So it has 3 bonds. So because of that, it's a very, very stable molecule. But ordinarily, this reaction should take place at moderate temperature. Thermodynamically, it should occur at moderate temperature. But because of this, then we call it activation barrier. And so this has been the major problem with ammonia synthesis overall. And what our catalyst, we think it does, is that it's able to overcome the need to break the dinitrogen bond. So we now have catalyst that is able to actually, you have nitrogen molecule, they're able to bind a nitrogen molecule at moderate temperature, and then you can further hydrogenate this material without really breaking the dinitrogen bond. I think this is actually why some of these catalysts we make are able to make ammonia at moderate temperature. So we work at different universities, so I think the focus is also different, but the goal is all to make better catalysts. So that is what we're all doing in this project.
How do we scale up that innovation and research from Christina and Peter? Okay, well, we try to take a conventional business model with a conventional solution, as for example, in the case of AMBHER, that is using for short storage the MOFs, and for long storage the CMR reactor. We take a conventional business model of for example, hydrogen refuel station that use as a buffer a pressurized tank, and then that model that is really well established, and we use this very common in our business. We know exactly all the variables and all the inputs that we need. We change one element, that pressurized tank. We change it for the MOFs, and then we try to by fixing an internal rate of return, we calculate the other variables, and we calculate what should be the hydrogen cost in order to make all the project feasible, and in order to deliver a final product that is also competitive as the conventional solution. So we tried to take a whole business model of a conventional solution and just take out one element and take in the other innovating technology. And then we fix what should be the efficiency, the energy consumption, the degradation, and we try to fix all that elements that, and then we give the feedback to the partners that are working on the lab scale and testing and so on, for they to give us feedback. So we try to work as much aligned as possible.
It sounds like your company is very fluent in doing all this scale up. Are there any bottlenecks or any challenges that you didn't face before?
Challenges? Well, yes, a lot. Also, with innovative solutions, the problem is that as we are a business, we want to make revenues, and we try to get the most technical, economical, optimized solution, and the suppliers of the tanks are well established, and it works, and the final goal is to make money. So price is very important, and in these innovating tech solutions, reach that parity and reach the price, a competitive price, is very difficult. That's why we try to involve us in these innovation projects to be as state updated as possible, and try to do these experiments and introducing. But yes, the most difficult, the big problem is to make that new technologies as economical, yes, as competitive as the conventional ones.
Yes, and how about Akin? You talk about you are also doing scale up, but mostly on the electrolysis of hydrogen. So what is your goal, or what is your
Yeah, here perhaps I can talk more on. I mean, as Tecnalia, basically, our role is to be between something like TRL3 and TRL6-7 on the different technologies. If we talk about, let's say, as a specific topic on ammonia synthesis or ammonia cracking, there my colleagues are working more on the development of the membranes, both for ammonia cracking or ammonia synthesis, together with the University of Eindhoven, in order to integrate these membranes on the reactor together with the catalyst that CNR or the University of Utrecht are developing. And I think there it is really important to match from one side the operating conditions. So the material should be this temperature, pressure, etc., good for the catalyst and for the membrane, because otherwise we can force one or the other. In order to, the aim is to have the best performance possible, but also we need to also consider always the durability. And we use this kind of projects in order to first validate like proof of concept, and then go to higher TRLs, doing, for instance, 1,000, 2,000 hour experiments in order to validate at a certain level that this technology makes sense, and then to someone like Maria from Iberdrola, so they can see that this technology could be useful to be implemented in the industry. And then it's also really important that this kind of components material should be scalable. Something that Christina or Peter, they are developing, also my colleagues from membranes department. These new formulations of materials, catalysts, then they should be scalable in order to someone else that can be a new startup or can be a new company that you can transfer this technology so they can produce these materials at a certain level so we can implement them in industrially.
So a very entire whole change. And so Peter and Christina developed the catalysis, and Technalia tested the visibility from tier 3 to tier 6, and then Iberdrola can do the final lab scaling in a company. So for four of you, do you find any missing link in between, or is it a very smooth processes?
Yeah, it's ordinarily on paper should be a smooth process, but it's about optimization because sometimes you develop the best catalyst, and then in terms of now upscaling it is either just like Maria said, maybe these catalysts are expensive, so the materials are expensive, so you might not upscale it easily, or even the way you've made the catalyst is a bit complicated, that it does not make it easier to be upscaled. And one of the problem we have also encountered, which is also there in the podcast, is that our material is sensitive to air. So if you have especially water, if during the upscaling it comes in contact with moisture, then it's going to the activity is going to be highly decreased. So then it means that if you want to upscale this catalyst, you need a special kind of environment to really do this upscaling. It can be done, but then of course maybe Technalia doesn't have this type of environment, this complicated environment, or special kind of environment to upscale this type of catalyst, and we cannot directly put our catalytic powders into their big reactors without doing other things like pelletizing them, and so it's something that these 4 years of AMBHER project, it's not easy to do this within these 4 years of AMBHER project.
I also agree. I think that there is a difference between sometimes our work, the work of academic people, and the work of industries, because generally I say that our goal is to find something that works. Then industries ask us how well works, how long it works, and the cost. That is a big issue for us. And also, as Peter said, also the scalability is really important to go to higher size. But I think that sincerely with the project, ANDREAH project, for example, that I'm speaking about it, it takes a big step to bridge the gap between academia and industry, because both the use of structured catalyst but also the use of a catalytic membrane reaction, both solutions are compatible with industrial applications. So I think that it is a way to reduce the gap between academia and industries. So it is a big quality of the project.
And Technalia, how would you bridge the gap? Do you have any measures to match the company's expectations, for example, economically competitive, while keeping the academia's research innovations, while you keep the strengths of the innovations in there?
Yeah, basically we are in between, let's say, in academia and the companies. We work very closely with the academia in order to try to, let's say, increase the TRL of innovations that, nice catalyst, materials, etc., that sometimes they develop or we co-develop as well. And then we are very close to the companies in order to understand really what are the KPIs for them. So what is really, as Maria was saying, the cost or the efficiency, or what are the, let's say, the pains for them, in order to try to translate that to what components, which kind of reactor, which kind of process we will need to get, and which performances in order to and then also to add this techno-economic analysis in order to be something that makes sense or not. So we can do very fancy catalyst or membranes or whatever, but then it should be something that it makes sense for the companies in the end. So this is something that we are like trying to bridge this gap.
Anya, can you introduce more? So do you have a complete complete group of expertise in forming this?
Yeah, we have different groups where we, for instance, in this specific case, we work on development of membranes. We work on development of new kind of reactors. Sometimes in collaboration, for instance, we have a close collaboration with the University of Eindhoven. We also work on techno-economical analysis. So there, for the each of the components or the reactors, and also for the whole system, and this gives us this, let's say, feeling of what these new technological innovations could make sense for one end user. That can be, for us, can be a company that we can transfer this new technology, or can be like an end user like a hydrogen or ammonia plant promoter like Iberdrola, for instance, or an engineering company.
Great. And for Iberdrola, you talk about you work for both AMBER project and ANDREAH project. Do you see any synergies when working two projects together? Because Christina and Peter is also working in AMBER and ANDREAH.
Yes, we see that the two solutions are very interconnected. We see the AMBER project as the first step, because you produce the hydrogen and you store on short term in the MOFs and long term in the form of ammonia using the CMR reactor. And then the ANDREAH project is the second step, because there you crack that ammonia produced and consume the final hydrogen on other regions where, for example, geographically the energy price is much higher, and you have the possibility to produce hydrogen in cheaper in geographies with cheaper energy, transport it to ammonia and then cracked and use the hydrogen in other geographies with higher prices, in other regions with higher prices. So we see that they are totally aligned, super interconnected.
Yeah, great. And what's your company's approach in joining this kind of EU Horizon projects?
Well, as I said before, we want to be the most update and know all of that kind of innovation in order to try to implement it in our projects. And for example, in the case of the ammonia cracking, there are no ammonia cracking facilities that are commercial. They're all in study and innovated, and the TRL are very low, so they're not projects that we can compare to us in the case of the hydrogen storage, that we can compare it with a pressurized tank. We can use them off, and then we can see exactly what should be the points that they have to reach and the goals. But in the case of ammonia cracking, it's totally new. So for us, it is very valuable to be involved in these projects.
Okay, so for Peter and Christina, for your background research point of view, what is the biggest challenge in having the ammonia cracking doing in a large upscaling? What's the biggest challenge?
If I think at the ammonia production and synthesis mainly, that the cracking, I think that the big problem is the production of hydrogen, because actually, for example, ammonia is produced by the Haber-Bosch process using hydrogen probably derived from fossil fuels. But to produce green ammonia, we want hydrogen coming from electrolysis, and actually it is still expensive and also energy intensive. Another thing probably could be the fact that the synthesis of ammonia is carried out at large scale, and if we want to produce on-site hydrogen generation, so decentralized production, we need to scale down. and this is have again significant and technological barriers to overcome.
I think if you talk to the industries, they have. Well, I was also so surprised recently. I was talking to some of the companies, and they feel that actually ammonia cracking is of more interest for them because they think, okay, well, ammonia synthesis is highly developed. The Haber-Bosch process has been optimized for more than 100 years now. So so the major problem with the synthesis is actually just like Christina has said, it's because of the way we produce the hydrogen. So the hydrogen coming from cracking of methane to steam reforming to get this is basically it pollutes, it leads to high pollution. So if you can actually make hydrogen in a renewable way, the green hydrogen, then we can really solve the problem of ammonia synthesis, because the Haber-Bosch process is actually optimized, so it should be fine. But cracking is something that it's not been investigated so much, because before now we don't care so much about cracking of the ammonia, because we can make hydrogen easily from other sources before, right? So we have but now it becomes important to begin to develop technology to actually to crack ammonia. And based on my own limited understanding, I've not seen any company that is out there that does ammonia cracking at large scale. So,
your perspective, is this challenge can only be solved by scientists, or does the community or government also can be part of the solutions? Can they have some measures that to take this a step further, so that, for example, ammonium cracking can have more commercial activities?
Yeah. Yes, I think that we need to do a big work like this, like today, in order to spread the message to the other people, citizen, child, pollution, and so on. Not only the academic people, not only the industries, but everyone must know about the problem, about the solution that also we studied, we proposed. And I want to say that the first thing that I learned at university, one of the first things that professor explained us during the course of renewable energies was the definition of sustainable development. And I remember the professor said that it is a way to satisfy our needs, but without compromising the possibility of the future generations to satisfy their needs. So I think that we need to work in this direction. So I really believe in my work. I know that it can favor the energy transitions, and I think that is a good thing to say to everyone. Everyone must know about this, and not everyone knows, I think.
I don't know if I may comment. I think it's really important to find the right applications for ammonia synthesis and ammonia cracking. I think we can say that this is a technology, but then we need to find which is the niche. And in the case, at least from my point of view, for ammonia synthesis, then this ammonia, as Maria was mentioning, it could be for fertilizer production. Then also another application that we are seeing is for ammonia for using as a fuel for maritime sector. And there in that specific case also there is a potential use of ammonia cracking on board. Basically that you have a ammonia storage tank in a boat, and then you make a partial cracking of ammonia, so you get a bit of hydrogen, and then you mix with ammonia and you feed this to the engine, because with this mixture is higher, you have a higher efficiency compared to pure ammonia in the boat. And then the third application that I see is on, as Christina was mentioning, so you produce, or Maria, you produce this cheap ammonia, you transport it, for instance, to Germany or Netherlands to a port terminal, and then you crack it, you get a hydrogen that perhaps you can introduce it in a hydrogen gas grid, and you can distribute it in a country. So there, I think these three specific applications, it seems, for what I see in this hydrogen and derivatives world, what it could make sense. And I think we should go to investigate and go into the direction from the research and also coupled with the industry and the market.
And for Maria, yeah.
Can I
please.
add something very quick? I totally agree with my partners, but I will also add that for us it's very important, for industry it's very important, the regulation, because until member states don't transpose clear guidelines of regulation with real penalties, the private sector won't make a move, and the private industries won't start investing and make this more quick and more effective. So I will also add that it is needed clear guidelines and clear penalties.
Yeah, I fully agree with Maria. It is something that yesterday I was in an event in Madrid with many companies, and they were saying that if we don't have this transpose of these directives, RED, 2, 3, etc., let's say the off-takers will not go for using alternative or renewable fuels for maritime or for the industry. So we need to push also in that direction, so we can also pull from that side. So everything can go, and we can develop novel technologies, etc., for the market.
Yeah.
And for industrial point of view, are the applications very attractive to them, or is still relatively economically not as competitive as recent fields? Do you think the
point is, the point is the cost, basically. So I think also Maria was mentioning before. Electrolysis, now the cost is a bit high, and it's a matter of, I think, scaling it up. That for instance, Iberdrola has one project 20 megawatts, probably we will need to go to 100, 200 megawatts projects in order to start seeing a decrease on the cost. Also, we need to consider the OPEX of the electricity for these electrolyzers. However, Bosch itself, it's a quite mature technology. If we can get something that can work at a moderate or more moderate conditions, I think something that the industry then needs to evaluate if they can integrate this and replace or make new plants for ammonia synthesis. This is something perhaps a question for Maria. For ammonia cracking, I think it's, as Peter was mentioning, it's a quite new technology or quite new focus recently, and there are some startups like H2Site that they are already trying to go to scale up this kind of ammonia crackers. But there is a lot to do there.
Which company is that?
H2Site. This is a company that we created between Tecnalia and University of Eindhoven.
Okay. So they also in the Netherlands here?
No, they are located in Spain.
Okay. Thanks. Yeah.
This time we should invite H2Site for a forum also. Okay, so
I'm making publicity as well, you see.
So from Atkins' words, it seems that the government has to take some move, for example, incentives or subsidies, so that the company will take a look at using these advanced technologies, because steel is a very high cost compared to conventional methods. And but other than this, do you think are there any things that the academia or RTO can do in order to accelerate the whole process? Or to
No.
So you mean what the academy can do to accelerate the process? I didn't get that.
For example, if there is a new, for example, if there is a new catalyst that is very very advanced or with high efficiencies.
Yeah, Cristina.
It is what we do every day, I think. We are working on this. So we are working to increase the efficiency of the catalyst, to integrate them with the membrane, to reduce the number of steps, to reduce the size, to lower the cost. So I think that we do a lot of work to change our society, no? For the energy transition at the end. So, what we can do more? I think I asked myself.
No, I think that is to how we connect the pieces of the puzzle. Basically, what CNR or Peter and the colleagues what they are doing, this new and innovative catalyst. Then we need to try to bring fast to the market. So basically it's how we scale up, how we test them in these hard conditions, long term, in order to try to increase the TRL until this product that we can do something with that, or to sell to a catalyst manufacturer so they can produce tons that can be integrated in a reactor that, for instance, I don't know, some Iberdrola's plant, or I think this connection between low TRL and higher TRL to the market, it is something that we need to be really connected. Otherwise, it's like we will spend like 10 years, or for instance, CNR and Uster, they are going to work on innovative catalysts, but in the market, they don't know. They don't really know.
They still remain in the laboratory. No, we need to pick them outside. So I agree with you.
There's a mislinkage from TRL3 and then TRL6, and then the industry expects something about TRL9. So there's a mislinkage here. So if, for example, if someone is opening a startup, say for ammonium cracking or H2 side, where should be the cutting point in your point of view?
Yeah, I think it's also about the demand and supply. So if you have, I think especially for the maritime industry, for the fact that this is also being done now, and there's also a big push to actually get some kind of if you think about sustainability, so you reduce your carbon footprint, then you get some carbon credit for that. So there's a push actually to begin to use this ammonia for in the shipping industry. So if you come out with a very good solution of the cracking, I think that then there's market for it. So it's not about the TR level, but I really think that you just need to come out with something that is something that has been tested and can work. Then I think that a lot of companies would be interested in investing into that. Of course, if you just make a new catalyst, you think, okay, this catalyst is good for ammonia cracking, and then you think it's very good, laboratory, you have demonstrated that, and then you want to upscale it, then there could also be some early investors that might want to invest into it, but I think it's still possible. It's just come out with something new or something already made that, okay, yes, this is more efficient now. I think there'll be people willing to invest in it. That's the way I see it.
Mm-hmm. I would also advise, if a new startup start working on ammonia cracking, to, as Ekain was saying, to perform a market analysis and identify the specific business needs in order to align all the research efforts with that specific needs of the business. So if I can also give another advice, I would say that.
It's expertise, right? Market analysis. Yeah. Okay. And Christina, do you have any things to add?
About this, I think we said almost everything. I think that we need to work together. I agree with all my colleagues. I probably see everything from another point of view because I'm a researcher, so I'm a part of the academic people. But if we work together and we can increase the use of renewable energy, favor the energy transition in general, as I said before.
Yeah, I think I will add that in that line that we need to try to understand each other, because we are in different, let's say, parts of the value chain. And for instance, we need to understand what Iberdrola is asking for, even that we want to make our best catalyst ever or best membrane ever. I think we need to understand what we need for this specific, let's say, process. And this is, I think, we need to, the language that we use, it should be something that we need to work together in that sense, because sometimes we are like in our war, but we need to always see what is the final objective.
So I think that it's a lot of things that you inspired us also for the forum for the next one. We have already some points to discuss into the next one. Thanks very much. We appreciate your time spending with us. Thanks very much. Okay.
It was
Thank you.
really a great pleasure. Thank you.
Thank
pleasure,
you.
yes. Thank you
Bye.
for the
My
invitation.
pleasure.
Bye.
Okay,
Thank
bye.
Thank you. Bye.
Bye.
Bye.